All right, so what's it say again?
Negative u equals 15.
Negative me. Like that?
Yeah.
Okay. What's understood to be in front of that u?
1.
So you can kind of rewrite it like this. Right? It means the same thing? So what if it was 3u equals 15? What would you do? Yeah, divide by 3. Why? Because right now it's multiplying. I don't want the stupid thing. Let me kill it. I kill it with the opposite. I can't kill it with fire. I kill it with division because that's the opposite of multiplication. So do you see how this is the same problem here, really? But what is it that I want to get rid of? And what's the negative 1 doing to the u? Multiplying. So how do I kill the negative 1? Divide. Yeah. So this side goes away. What are we getting the other side? Yeah, negative 15. I like. Is that cool? Is that all right?
Yeah.
Yes.
I tried to do it like by myself, and I put a negative under the negative to cancel out, and I still got the same answer.
Of course,
Can you possibly
sure.
do that?
Sure, but if you write this and you put underneath the negative sign, that doesn't mean anything. That has no meaning. You have to give it a that, yeah. So there you go. Yeah. I like it. So you did the idea, you just didn't represent it correctly. Yeah. Okay, I like it. You guys doing all right? I don't know, he gave up. I don't know why these poor guys are on. You're already sleeping good. You can sleep. Okay. Yes?
I have not done 2.2 homework yet, but from 2.1 when it was addition and subtraction, is that the only time that you're messing with the negative or the positive? So like if that was an addition.
Oh,
column-
yes. Okay. So, the biggest mistake I see on a problem like this, or maybe actually it would be something like this. It's a little weirder with just the negative. So if I had negative 2u equals 8, I'll always get somebody that does this. And you already know what I'm going to do.
Yeah.
Right?
Yeah.
And your brain is like, what the hell, man? What's wrong with that shit? Opposite of negative 2 is plus 2. But you're not oppositing the number, which I love the English language that allows me to verbalize that poor word. But you're not doing the opposite of the number. You have to do the opposite of the operation. The only thing that can kill what is currently there is the opposite operation. You guys see what I'm saying? So the operation there, of course, is multiplication. So if I want to kill the negative 2, I have to do the opposite operation. So what's the difference between that and this? Well, what's the operation? How do I kill it? Addition. So it's not, I'm changing the sign, it's the operation. Now, negative and subtract mean the same thing. So that's why it gets confused in our heads.
The same?
Say again?
Excuse me, the one is the same?
No. So this is u minus 2. It also could be looked at as u plus negative 2. So we always think that negative means the opposite of positive. So it gets in our head. That's not true. It's when it's a minus, the opposite of it is add. That's operations. Right? You guys with me? You guys all right? So you got to look at the operation. Let go of if it's positive or negative. So up here, the operation is multiply. So how do we kill the negative 2? Divide. That kills it. What do I get?
6.
4.
What am I doing?
Negative 4.
Dividing. So it's negative 4, yeah.
Negative 4.
Right? I'm not doing 8 minus 2. I'm doing 8 divided by negative 2. You guys with me? A little bit? You guys, so the main idea here is focus on the operation. Let go of what it is, negative, positive. Don't even think about it that way anymore because that's what leads to people adding 2 here. It doesn't make any sense. Addition can't kill multiplication. Right? It's not its job. And of course here I would just add because that's the opposite of subtract. It's crazy. Ah, yay. Is that all right? You guys all right? Yes.
Oh, no, was it 8 to 10, okay.
Yeah, 8 plus 2, 10. And this one's 8 divided by negative 2. Yes.
Because we have that divide. Oh, it's the-
Division, yes, that's division, and this is actually combining them.
Okay.
I like it.
I got it.
What if you wanted to do u times -2, how would you write that down?
Oh, that's this.
Okay.
Yeah. Because it's a little wonky to write. If I wrote it like this, I'd have to put parentheses around there.
Okay.
So I knew it wasn't subtraction. So that's why we always put the numbers as coefficients in front. So then I have to write it less wonky. I like it. You guys know the word wonky? Hopefully it's still out there. Yes.
Can you do whatever the problems are for 2.1?
Yeah, sure. What is it? I think I gave all mine away. So what's
It's m/7 plus n/7. I'm so confused on that part.
m over some plus?
10/7.
All right, now help me out. We did look at this, so I'll do this a little quickly. How do you do this? What's 5/9 plus 2/9?
7.
Is that cool? 7/9. We got to start there because if we have issues with this, we're never going to be able to do this. So this is really just this problem. I can't put them together though. So what did you really do here? Didn't you do whatever this is plus whatever that is over the common 9, right? And then I could do one more step because 5 and 2 are alike. All right, let's do the first step up here. What do? You take this guy plus the other guy over the common 7.
That's it.
Can I go another step? No, they're not like terms. So like one year, one of my students said, "Oh yeah, that's easier because I have to do as much." I'm like, yeah, you just stop right there. You don't have to put them together because they can't go together. You guys semi with me? In one sense, these are like terms because they have so many sevenths plus so many sevenths equals so many sevenths, right? The bottoms are the same, so they're like in that way. That's why I'm able to put them both over 7. I like it. Okay. Anything else? All right. So, I'm going to get back into it. I can't remember last time I did announce a quiz, but of course I announced it after I finished taping, so I was like, oh shit, what day did I say? I'm pretty sure it said Tuesday, and that's what it's going to be. I was almost certain it didn't say today. So we do have a quiz. What in the world was that? A quiz tomorrow. And it's chapter 1 through, I think I said 2-2. Or did I say 2-1? 2-2. Look at you guys being honest. Kicks ass. It's horrible that what the bar is nowadays to be a good person. Yes?
Now on m/7, I always thought that m represented 1.
Yeah. If that was true, why would we use m? Why wouldn't we just put 1?
I know, because on multiplication.
You're not, I know what you're thinking. I think I know what you're thinking. What's in front of the m? 1. Is that what you're thinking? M, I don't know what the hell it means. What could m be? Anything. 1, 2, 3, 18, 4.7, -11. It could be anything, right? It's a variable. If m had to be 1, why the hell would we use it? We would just put a 1 there. So it's just like x. In fact, what's special about x? Not a damn thing. It's just the one we decided, what do you want to use most often, guys? X. That's not really the history. You should look it up. It's a neat history. It has nothing to do with pirates, unfortunately. Right? There's a theory about X marks the spot, but no. Maybe? You guys are right?
So why can't you not add 1 plus 10?
Because m is not 1.
Oh,
M is m. So when I do this, if m was 1, what's 1/7 plus 10/7?
7.
If m is 1, what do I get on this side? 11/7. So I've written an expression that is equivalent to what this would be if I knew what m was. But I don't know what m is. Yeah. That'd be kind of amazing if we could choose whatever we want to for a variable. There would be no more letters, but we would, we'd be living in caves and all this kind of shit.
Because in
No
division
phones.
multiplication, x is understood as 1.
No. Come on now. I think you're saying what's understood to be in front of x. 1. Because if I say x plus 4 equals 11, Is x gonna be 1?
No.
No, it's whatever it needs to be to make this true.
Oh.
So if it's just sitting there without an equation, then it actually is whatever the hell it wants to be, right? So if you always have 4 more bucks than I do, that's just the way it always is. It's weird. And you know how much money I have, then you have x plus 4. If I have x, you have x plus 4. Do you see that? That's the modeling. That's what variables are for, is for saying, I don't know this one piece, but I know this other piece relates to that. So algebra gives me the right to write the second dude and related to the first piece. Right? So if only I knew how much money I had, I'd know how much money you have, because you always have 4 more bucks than me. It's just the way the universe is. Good 10. Well, you got 14. Oh shit, I should have known. Okay, maybe. I love you guys. You're all like, whatever you're saying, dude. What is this? Does this make sense? Are you guys with me?
Yep.
So I can't say what a variable is unless it's in an equation that I might be able to solve to see what it
This
is.
is all for X.
Yes, this is, but this wasn't an equation. It was just an expression. Kick ass. All right. Anything else? Okay. So did we? Let's see. I gave out this handout last time. I don't think we finished it. Is there anybody need that handout? Did I give that to everybody? This is solving equations handout. You guys have that? Cool. Yes? No? Maybe? No? You were here last time. You didn't have it. I only have so many.
We need a scan chart for the wall.
Oh, okay. It always has to be somebody that asks this question, so I'm not taking anything out on you. If you have a math teacher that uses Scantron, they are not a math teacher. I don't know what they are. Because math is the work you do to get to the answer. The answer being right is nice. If you're going to be out in the real world making a bridge, I want you to get the answer right. But you're not in the real world, not making bridges, no one's going to die. The more important piece in this class is the work you do to get to the end. So if I'm grading a problem, and you show me you understand the concept, but you have a brain fart here and say 2 times 3 is 5 or something, you might not lose any points. I might just put a little, I know you don't know this, think this, right? But if you do a problem, you show me you don't even understand what the hell you're supposed to be doing, you're going to lose a ton of points, right? So I grade heavy on concept. No Scantron is the short version of everything I just said. I wish, man. Oh, man, I have such an easy-ass job. Online homework, Scantron. I could kick back. Shit. I don't know why I don't do this much. So, remind me, last time we got through, I think the second row, right?
Yes.
And we didn't do the last 2 problems, is that right?
Yes.
Okay.
I go, excuse me, I
Yes.
go to website to see the.
Oh, yeah. Somebody just told me it didn't go up. I think I started the upload, but I don't know. I got to double check.
Not lucky.
So last Thursday's video is not up yet. Sorry.
Yeah.
You could just email me the minute you notice that or something, because something went wonky. It's a word of the day, man. Between the computer, obviously, so I got to re-upload it. Yeah. So last Thursday's video is not up, if you're looking at the videos at all. And if you're like, what videos? So I take videos of the lectures, put them up on YouTube. It's the last link on the website. Okay. So let's take a look at this. So this is 1H on the back of that solving basic equations sheet. Okay. Does everybody see this one?
Two,
What's up?
which one? H.
H.
Okay.
Yes. Cool. I like it. So what would I do first here?
Distribute the 2.
Yes, and the way to realize this is normally what you're trying to do in the first few steps is get your like terms together. But do you see how some of your terms are stuck in here? So I know some of you guys are like, well, of course you distribute first, but some of us are like, I don't remember what the hell. We did talk about distribution property, why it works, why it makes sense before. But I want to get my like terms together. Why can't I put these together? Because I don't have a 1. I have a 2. I gotta first know what the hell the parts are before I can start putting the parts together. So that's why almost always the first step is distribute where we have those parentheses with something in front. I like it. So of course you get
2x plus 2.
2x plus 2, and then everything else is still here, just waiting. Now what can I combine on this side?
2 minus 1.
By the way, let me say this right now. I want to catch this in the, nip this in the bud. There it is. What would you tell the person that does this?
No.
Don't become a teacher, that's probably. But yeah, you're right. Why not? What are they thinking and they're not doing correctly?
You gotta do it on the other side.
Yes.
That-
Whatever you did on one side. So overall, what did this person do to this side? Added
It just made it
2.
harder.
And what they do to that side?
Nothing.
Not a damn thing. So this side got twice heavier. That's not in balance anymore. Your equation's shit. Right? But I understand your brain says, I've been told to do the opposite, but that's to both sides of the equation. I'm not even at that point yet. Before I start doing both sides of the equation, I make each side as compact as it can be. I get all my like terms together. Drink some water, Jeff. Water. At least that's what I'm going to tell you that is.
It's killing that Kool-Aid.
Sure. So what do I hear?
1.
That's craziness. So now you get to make a decision. So very often equations get to this step. And now you can decide. You need x's on one side, numbers on the other side. I don't care which side it goes. But normally I try to keep my x's positive. So I don't want to subtract 2x from both sides, because then I would have a negative amount of x's over there. I want to instead
Take away 1.
go the other way. Subtract x from both sides. Do you see how I'm getting all my x's together?
Yeah.
Because I know my goal is x equals number. So I'm going to get my x's on one side. So here I got x,
Plus 1. Equals 3.
coolness. I see I'm being very nice to myself. If I change one piece of the equation, I keep the rest of it the same so I don't lose anybody. Nobody kind of floats to the other side. I always love that shit. The equals goes away and then it kind of reappears at the end. No, don't do this stuff to yourself. You got to keep clear what's on each side, what's combining with what. And the last thing I need to do is, so I get x equals crazy sauce. Right? Is that cool?
Yeah.
How do I check that?
Plug in 2.
Plug it in where?
For both x's.
Both x's, kick ass. So I always get somebody check something and they only put it in one x. Doesn't make much sense. You're not going to get very far. So what's 2 plus 1 times 2
6.
minus 1? 5. And sure enough, 3 plus 2 is?
5.
Check. Right. Yes?
Can you explain the second step and the third step? 2x
Here?
and then, yes.
So are you cool
I'm
with...
sorry, the third and the fourth,
Oh, this step.
yes,
So what's 2 minus 1?
1.
So that's just combining like terms.
Right, right.
So before I do any movement from one side to the other, I want to consolidate each side so I get less stuff to look at.
Okay, but why is 2x minus 2x, minus x equals x? Oh,
No, come on now. So that's where I am now.
yeah,
How do I get the x's together? I subtract x from both sides.
right,
Okay, so that's all we did.
so it's 0,
On that side, that's why there's no x's here, right?
okay.
I could put plus 0, but that doesn't really do
Oh,
anything.
because there are 2 x's, okay.
So these died, the 3's still here, and 2x minus x is 1x. Cool. And then I just moved the number the other way. And then I know what x is. Kick ass. So I really want you guys, this is not me saying this is where equations come from. Remember the top of this? But it is interesting to see it happening in reverse. And we did it up on the board. Right? I started with x equals 3, and then I doubled both sides, so I got 2x equals 6. You know, so all we're doing was trying to undo all that stuff that happened to the variable.
For quizzes and exams, is showing the work enough, or do we have to plug it back in and then show that work? as a
If I
second
say
homework?
check it, you better. If I don't say check your solution, you don't have to. Is that cool? Yes,
Is that same for homework as well?
same for homework.
Okay.
Yeah. If I take points off for something they didn't ask you to do, that's a little evil. Now, the one thing that's not in that rule is showing your work. I don't care if they don't say it, I said it. So you gotta show me the work. Okay. So you guys try that last problem out if you haven't tried it yet. 1i. Whatever gets floats your boat. Yes. You got it? All right, hold on. Okay, we'll find out. Something interesting might happen. Yes. Yes.
I need help on president one, 2.2.
Yeah, so just be one X. Yeah, it should be the X on that side.
Oh yeah. Okay, we can do that. We'll do that one together. Let's see.
Is that combined?
Be careful. What does this mean? Where's the equal sign? How did you get there?
Cause I
How do you get your, like right here, how do you get your x's together? Yeah, do it.
Okay.
See what happens. Yeah, but it's not the answer yet. We did talk about this, I think we did last time. How to interpret the answer you get. Good. Distributed -2. Yep. 2. Coolness. All right. So one of the most immediate mistakes people make is, I'm going to make a mistake. Here we go. Okay, where have I made a mistake?
You didn't time -2 and
Good. What am I distributing? -2. -2 times x is -2x. -2 times 3 is -6. Don't worry, man. We're going to catch up to you. We're going to interpret what the hell it means. So then what can I put together on this side? Yeah. -2x plus x is -x, and 11 minus 6 is...
Oh, no, it's just fine.
All right, how are we doing there? Is everybody with me there? That already looks weird. But just keep going. How do you get your x's together? Yeah. You don't let both sides tell you what to do. I don't want that x there. Let me add x. You just do it. What I love about you guys is you hate the variable, but this is the one where you're like trying to save it. I got your variable. And normally I'm like, you hate it. Why don't you just let it? It wants to die. Let it, right? Algebra's got a right to die thing. Die, it's dead. What do I have left? Don't circle this. That's not the answer. In fact, when we did the earlier equation, I wish I could remember what we got at the end. X equals something. When we do a normal equation and we get x equals something, when this is true, then the original equation is true. That's why to check it, I make this true by plugging one in. And then I see if the resultant thing is true. So when is this true? Always. So it doesn't matter what the hell x is. No. So it's always true, therefore the answer is all real numbers. That might be a little bit trippy. So what that means is if you plug a 7 in, it's going to work. If you plug a -2 in, it's going to work. If you plug in a square root of 11.489, it'll work. Yes?
So when you get it down to just two numbers, that's when you stop?
Yes. So since this is true, and look at this, does this make sense? Do the x's matter?
No.
They died. The x's don't matter. So since the fundamental piece of this equation is true, it doesn't matter what the x value is. It would cancel anyway. if I got 5 equals 6 here, then the x's can't save the equation's s. It's false, no matter what. So that's a very special condition. If the variables cancel in an equation, it's going to either be all real numbers or no solution. So here's a very simple example of that. What does this equation mean? I love that question. What is that equation looking for? It's looking for a number. So when I add 1 to it, it's the same as if I added 2 to it. Do you guys see how to say that? That's how you say that equation in English, right? Now, on the surface of that, can you come up with a number that's the same if you add 1 to it or 2 to it?
No.
Is there any number that's possible? No. So whatever the hell I do mathematically, the answer better be nothing, right? Because we already know going in, ain't no way this is going to work. Can't like it. Thankfully, I don't teach English. My awesome grammar. Yes?
What did you do to the negative 2x?
What's negative 2x plus x?
Negative x.
Just combine them, right? Once I distribute, then I get my like terms together. 11 minus 6 is 5. Negative 2x plus x is negative 1x. If I owe you 2x's and I find one, now I just owe you 1x. Maybe? Yes?
So this is trailing off just a little bit from the problem, but I wanted to know how do you find out if it's no solution?
Oh, we're about to get one. What would I do to solve this? How do you get the x's on one side? Subtract x, right? You don't let the problem tell you what to do. We're the humans. We do what we know we're supposed to. You don't go, oh, I can't do that. No, you just do it. Da, da. 1 equals 2. What's the answer then? No solution, yeah. And we knew from the beginning. I love it. You were about to get upset if I said anything other than no solution. But yes, of course it's no solution. We knew from the beginning it was no solution. There's no numbers I can add 1 to, and it's the same as if I added 2, right? Because that's how to say this equation in English. So again, whatever the algebra did, it better agree with that shit, because we already know that's the way this is supposed to work. So that is one thing that I don't do very often with students, because you got to get the technical side of this down. But very often you can step outside of the math and just look at what it's saying. This is a beautiful example. Ain't no way it's going to work. Just looking at what the equation needs. It needs this to be the same as that. Nope, no number can do that shit. Now here's one where people confuse it though. I love this problem. You would, Jeff. I know. Whoa. So watch. Let me add one thing and there's going to be no problem. What would you do next? Here. Not really. There's no like terms to combine. I can start moving things though. What's in the wrong place? 2x. Supposed to be over here with the other x's, right? So what would you do here? Yes, right? So over here, it's the same freaking thing. Are the x's together? No. So subtract 2x. What do you get? Equals 2x minus 2x? Nothing.
Well,
Minus.
minus.
Yes.
Sorry.
Let me stop for a minute. You guys with me? But do you see how that equation is very confusing? But all I have to do is put that there and all of a sudden we're pretty decent with, oh yeah, I know what to do next. So if that wasn't there, why would it be any different? Of course not. I'm still trying to get my x's together. Right? So how do I end this though? End it. So here's another one. What if it was this? What would you do? How would you solve that?
Divide.
Kill the what? What do you want to kill? Oh, kill it all, Jeff. Just make it stop. I want to kill the 3, right? How do you kill it?
Division.
Divide by 3. What if it was this? So you divide by 3, right? You'd be done. What if it was this?
Still divide by.
Get it? Yeah. What if it was this? Divide by 3. What if it? All right, right? So what if it's this? You freaking divide by 3. You want to get the x by itself. It's not by itself. Stupid times 3. So let me do the opposite operation and kill it. But we let the other side tell us what to do. I'm like, shut up. I'm the human here. You're just a dumb little number we made up. So divide by 3. What's 0 divided by 3? 0. And why does this make sense? What's the only number I can multiply by 5 and it's the same as if I multiplied it by 2? 0. What's 0 times anything? So it makes sense the answer to this is 0. You could have actually kind of reasoned it out. You don't have to, though, because algebra does it for you. Maybe? Maybe? Not at all? Some of you guys? Okay. All right. Oh, what was the question back there?
101.
So it was 2/3 x equals, right?
Equals 48.
48. Okay, that's a beautiful problem. And this is 101
Yeah.
in chapter 2, yeah.
Yeah.
Oh, shit. So let me ask you this. Let me break this down. What if it was this? What would you do? Divide by 2. What if it was, so I divide by 2. What if it was this? Multiply by 3, right? Well, I've got both of that shit. I got 2x and I got x and I got it over 3. So let me multiply by 3 and divide by 2 at the same time, affectionately known as multiply by the reciprocal. Does that sound familiar?
Yeah.
If I multiply this side by 3 over 2, I better do what at the same time?
The other half is that.
And then what happens here? The 3's
Die.
and the 2's.
Die.
And I get x by itself. Yes?
Yeah.
Yes.
And then I get whatever the hell, what 2 goes into 48. That's right, kids, 24. 24 times 3. 72.
Yeah.
Does that sound familiar? Multiply by the reciprocal? And really, it's a shortcut of doing two things. Let me do another problem, the long cut. So if I had 5/7 m equals, what, Jeff? I don't know, man. Let's do 40, sure. Okay. So watch. The worst part about this equation is the fact that there's a fraction. Are you guys with me? You guys agree? I'm not saying you have to. I'm just saying most humans would say fractions make things worse. That doesn't mean we shouldn't have to be able to handle them. But even for somebody that can do math really well, it still makes it worse. So let's kill it. How do I kill, why is there a fraction? Because it's divided by 7. So how do I kill that? Multiply by 7. Just going to do one thing at a time. Right? Now there's no fraction, right? What am I left with? 5m